I just wanted to show two more examples of adding polynomial fractions with unlike denominators, just to make sure that you have all the examples that you need. So the first thing that I'm going to do is I'm just going to find out what are the factors in these denominators. So I'm going to go ahead and factor these binomials. So 8. So two things that multiply together to give me negative 16 and add up to negative 6. So one of them is going to be a negative and the other one's going to be a positive, and I think that's going to be negative 8 and positive 2. And then this pair here, we've got 9, two things that multiply together to give me negative 40. So again, the one's going to be negative and one's going to be positive. And they have to add to 3, so we're going to have negative 8 and positive 5, that pair. So now I'm going to find the least common denominator by identifying all of the factors. I need to take into account each denominator, each factor in the denominator. So I need one x minus 8, one factor of x minus 8, because there's one in each of them. I need one factor of x plus 2, and I need one factor of x plus 5. So that's what my least common denominator is going to look like. The quantity x minus 8 times the quantity x plus 2 times the quantity x plus 5. So I'm just going to identify which factor is missing in each of those so I can make a least common denominator. So here I've got 8. I've already got the x minus 8 factor and the x plus 2 factor, so I'm going to need that x plus 5 factor. So we're going to add that in by multiplying the numerator and the denominator by x plus 5. For the second polynomial, I've got, or for the second fraction here, I've got 9 over x minus 8 and x plus 5. So I've already got these two factors. I just need the x plus 2 factor. So I'm going to just multiply by 1, by the same thing, numerator and denominator. And so now I can write them all over one common denominator, right? X minus 8 times x plus 2 times x plus 5. And I'm not going to distribute these back out. It's actually lovely to have them as factors because then I'll be in a good position to move forward. But up here on the top, because I'm adding these, I might be able to simplify my polynomial if I do actually add them together. So I will distribute here. So I've got 8x, 8 times the quantity x plus 5, which is 8x plus 40. And then I'm going to add to that 9 times the quantity x plus 2, which is 9x plus 18. And so here, notice I can combine my like terms because I'm just adding. So that's going to give me 17x plus 58 over x minus 8 times x plus 2 times x plus 5. I'm kind of tempted to factor out a 17 here, but it turns out that 17 times 4 is 68, not 58. So that's the solution. And of course, if we're considering what our values can't be, we can't have x equal to 8, negative 2, or negative 5. One more example, this one is where I'm factoring with a leading coefficient. So if I consider how to factor this one, remember that I need to multiply the a and the c terms. So I need two things that multiply together to negative 24 and add up to negative 10. So it's going to be negative 12 and positive 2. So if I expand this, 3y squared minus 12y plus 2y minus 8, and then group it, 3y squared minus 12y plus 2y minus 8, and then factor out my GCF, so 3y times the quantity y minus 4 plus 2 times the quantity y minus 4. So now my factors are y minus 4 and 3y plus 2. So I'm just going to rewrite those there. So that's y minus 4 and 3y plus 2. And I'm subtracting y squared minus 6y plus 8. So here I've got y, it's got to be a positive, so the signs have to be the same. So y minus and y minus. And so that's going to be negative 4 and negative 2 multiply to positive 8 and add to negative 6 with a 3. So now I'm going to consider for my least common denominator, what are the factors that I need? And so I need a y minus 4, I need a 3y plus 2, and I need a y minus 2. Note that I don't need to duplicate any factors, right? If I've got it in one place, I don't need y minus 4 squared. So I'm just going to identify any missing factors. So for the first one, this y minus 2 is missing, so I've got 12 over y minus 4 times 3y plus 2 times y minus 2. And I'm going to do the same thing on the numerator. And here I've got 3 over y minus 4 times y minus 2. And I'm missing this 3y plus 2, so I'm going to multiply that in, 3y plus 2. I'm going to put those in parentheses just so I don't forget that they're factors. So now I've got a common denominator, this lovely y minus 4 times 3y plus 2 times y minus 2. That's my nice, lovely denominator. And now I'm just going to distribute these in. So that's 12y minus 24. And I'm going to be careful here. I'm going to think of that as a negative 3, right? That minus sign. So it's a negative 3 times 3y. That's negative 9y. And negative 3 times 2 is negative 6 or minus 6. So then combining like terms, I'm going to get 3y minus 30 divided by y minus 4, 3y plus 2, and y minus 2. Remember to exclude our values, so y cannot equal 4, y cannot equal 2, and here this one might be a little trickier, so maybe we'll solve for this. 0 can't equal 3y plus 2, so solving here, y can't equal negative 2/3. Okay. So those are our excluded values. Okay, I hope that helps, and good luck in your reviewing. Thanks.